Hello, in this video we're going to use application Flowy14 to write an algorithm that determines the intensity of two vectors and prints the higher of those values. Both vectors have starting point at 0 and are each given a point of the form, such as A, B, and C. Let's proceed to application Flowy14. Let's delete our previous project. And to our dashboard here, once we cleaned it up, we can begin designing our flow. So click into the upper left corner where it says commands. This will open up our command menu. You can navigate to each command manually, or you can use the search option up here. So to begin designing our flow, you will always need the first command being the start command. For today's purposes, we'll add a lot of commands. First will be 6 of input commands, then that'll be followed by 10 mathematical commands, out of which 6 will be multiplication and 4 addition. Then we'll have 2 square root commands, 1 for each result, and then we'll have the if then command, if then loop command to compare both results, and then we'll have 2 output commands added to that if then loop, 1 for each possible result, and then we'll close it off with the end command. So let's proceed to start adding our input commands, which we need 6 of. So let's type input. It should come up as one of the first available commands, and we'll need 6 of these commands. Four, 5, and 6. Next, we'll need 10 mathematical commands. So just type the word math. And let's proceed to add the first 6, which will have to be turned into multiplication. We'll do that once I have 6 of them added to the dashboard. 4, 5, and 6. So we'll need to turn these these mathematical commands that by default come with plus sign into multiplication. So once you click into the command, once the command is highlighted, you'll see down below here options that you can turn it into. So we'll need multiplication, and you can see once I click that, the plus sign turned into multiplication. I will perform the same exercise for the remaining 5 addition commands. So highlight it and click into multiply, and the same for the other 4. Okay, and now we'll need 4 more of mathematical commands, and these will be the addition commands. So we will just leave them as they come by default with the plus sign. We won't have to convert them into any other function. So 4 mathematical commands, and next we'll need 2 square root commands. So just type the word root, 1 for each result. To that we'll need to add our if then command. Just type the word if, just type if. By default it comes with the less sign, but once you have it highlighted, you have different options at the bottom to turn it into. We'll need the less or equal. So you can see that the sign turned into less or equal. And now to the to our if then command, we need to add 2 output commands, 1 for each result. And once you're satisfied with the design of your flow, so I'm just confirming I have the right commands, 6 of our input command, 6 of the corresponding multiplication commands, and 4 corresponding additions, and then 1 for each result, square root, 2 outputs on if then command. And so once you're satisfied with the design of your flow, you can close it off by adding the end command. All right, so we are ready now to start connecting our commands. The way I need to connect them for today's purposes is that I need to connect each input command through its outbound data connector to its corresponding multiplication command. So the first input will be connecting twice to the first multiplication, the second input to the second multiplication, and so on for 6 of the multiplication and input commands. And next we'll connect the multiplication result into our addition commands to obtain the results. Then we'll calculate both results and then we'll compare which one is bigger and print the result. So let's begin by clicking into our input command, and in the green area click into that. That's the outbound data connector. Once you click into it, you'll see all the available highlighted inbound data connectors. And as mentioned, we need to have this input command fed twice into the first input multiplication mathematical command. So click into it's both available inbound data connector, which the pluses have now turned into minuses. That means the connections have been made. Once you click off of the design, you'll see the yellow arrows indicating how both commands have been connected. So we'll perform the same exercise 5 times more for each of the input commands. Clicking to its outbound data connectors and twice on the second corresponding multiplication command into its inbound data connectors. Same for the third input command, connected into its third corresponding multiplication command. Same for fourth, connecting to the fourth multiplication command, and so goes for the fifth input command, and the final input command, sixth, connected to its final available multiplication command. So now that we've connected the input commands with its corresponding multiplication commands for calculation of the results, we can now begin the addition of the multiplication results. So connect the first multiplication, the first and the second multiplication result to the first available addition command. So the first multiplication command, we clicked into its outbound data connectors, and we'll click into the first highlighted available inbound data connector on the first addition command, and we'll do so the same with the second multiplication command. Click into the green area, which is the outbound data connector, and connect it through the into the second available inbound data connector on the same multiplication on the same addition command. So to our second addition command, we'll connect the third multiplication result to its outbound data connector into the first available inbound data connector on the second addition, and then we'll connect the result from the prior addition of the first two to the second addition. So click into the first addition command, into its outbound data connector, and into the second available inbound data connector on the second addition. That way we're adding all of the multiplication results. On the third available addition command, we are connecting the fourth and fifth multiplication results. So clicking into the fourth multiplication result, into its outbound data connector, and into the third addition command into its first available inbound data connector, and then doing the same for the fifth multiplication result into its outbound data connector, and connecting it to the second available inbound connector on the third addition command. And so for the last available multiplication result, the sixth one, we'll connect it through its outbound data connector to the last available addition command through its first inbound data connector. And next we'll connect the result of adding the fourth and fifth commands. So click into the addition command of the fourth and fifth and connect it to the final addition command to its via its second available inbound data connector. Okay, so now that we have the results of our multiplication connected into the an added app, now we need to connect them to our square root. Let me just make sure that we have our connections properly here situated. So I'm just gonna follow the arrows for a few minutes. So we have connected properly our commands, and I'm going now to connect the second addition that has like the first three results of the multiplication, and the fourth addition that has the second three that has the other three results of the multiplications added. So basically, this addition has the first three multiplication results added, and then the fourth addition command has the fourth, fifth, and sixth result of our multiplication added. So I need to feed them to each corresponding square roots to obtain the results, and then we'll compare the results through our if-then loop. So clicking into the second addition command and into its outbound data connector, to connect into the one and only available inbound data connector on the first square root command to obtain the first result, and then doing the same for the final addition command into its outbound data connector, and connecting into the second square root command through its inbound data connector to obtain the second result. So now that we've obtained both results, we need to now feed the results or connect the results to our if-then command here. So we'll click into the first result, into its in green outbound data connector, and click and connect it to the if-then loop and into its corresponding output command, and click off of the design to make sure that we've connected them properly. So it's the first one, okay. And now click into the second result, into its, I will just bring it up a little bit closer. So we're clicking into the second square root, which is, in other words, our second result, into its outbound data connector in green. Click into it, and we're feeding it or connecting it to the second available inbound data connector and its corresponding output command to compare the results. All right, so we have successfully designed. I'm just gonna click the commands menu to close it off to make the dashboard cleaner, to make more room to accommodate our extensive flow. So we've designed our flow, we've connected our commands, and we'll now proceed to execute the flow by clicking run. So each input command will ask us with the numeric pad to enter a digit. For our exercise purposes, I'll just enter 1 through 6. So 1, but you're welcome to enter any digits. Just for simplicity purposes, I'll enter 1 through 6. 3. You can see the multiplications are being performed. 4. 5. And 6. Enter. So 2 times 2, 4, 9, 3 times 3, 4 times 4, 16, 5 times 5, 25, 6 times 6, 36, and then we're adding the results. 1 plus 4, Perfect. So we have the results of our multiplications have been added, and then we have come to conclusion to have two results, two different square roots, one at 3.74 and 1.81 at 877, and so the bigger result has been printed, which is the 8.77. So thank you. This brings us to the conclusion that using application Flowy14, we can write an algorithm that determines the intensities of two vectors and prints the higher of those values or results. Thank you.